Hello everyone, I am Jason Janjidoke from BSID Matoy. So today I've discussed to you the linear programming problem by using graphical method. So let's start!
맞은 것처럼 뱅뱅
What is linear programming? Linear programming, mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning and industrial engineering, and to a lesser extent in the social and physical sciences. So next is the graphical method. Graphical method allows solving simple linear programming problems intuitively and visually. This method is limited to two decision variables only. Next is the steps for graphical method. First step, formulate the LPP or the linear programming problem. Second step, construct a graph and plot the constraint lines. Third step, determine the valid side of each constraint line. Fourth step, identify the feasible solution region. And fifth step, find the optimum points. Sixth step, calculate the coordinates of optimum points. And the last one, evaluate the objective function at optimum points to get the required maximum minimum value of the objective function. So given the example, maximize g equals 3x plus 7y and subject to two x plus 4y less than or equal to 24. The next is 2x plus 10y less than or equal to 42. And the decision variables x and y greater than or equal to 0 is a non-negativity constraints. So this is our objective function is to maximize, then our constraints, then our non-negativity constraints, and x and y is our decision variables. First, we make these constraints to a equality side. So 2x plus 4y equals 24. And then the next constraint is 2x plus 10y equals 42. So before getting the coordinate points of this, we must solve for the x and y of each constraints. So we assume that y equals to 0. So our first constraint is 2x plus 4y equals 24. So if y equals to 0 is 2x plus 4 times 0 equals 24. Then 2x equals 24. Cancelled out this 4 times 0. So divide both sides by 2 to get the x. So our x is 12. And then if the other one, if x equals to 0, so our constraints is 2x plus 4y equals 24. So 2 times 0 plus 4y equals 24. So 4y equals 24. Cancel out this 2 times 0. So divide both sides by 4. So our y is 6. So our P1 is 12, 0. And our P2 is 0, 6. So next, we solve the second constraints. So the second constraint is 2x plus 10y equals 42. So we assume that if y equals to 0, so we process this. So 2x plus 10 times 0 equals 42. And then we get a 2x, cancel out this one. 2x plus 2x equals 42. Divide both side by 2 to get the x. So our x now is x equals to 21. And the other one is if x equals to 0, so our constraint is 2x plus 10y equals 42. So 2 times 0 plus 10y equals 42. So 10y equals 42. So cancel this 2 times 0. So divide both side by 10 to get the y. So our y is now is 4.2. So our Q1 is 21, 0. And our Q2 is 0 and 4.2. So we must plot this in the graph to find of this solution. It's occur in the extreme points of corner points. So we show them in the graph. So in our initial graph, the graph we just take the first quadrant since both x and y are positive because the non-negativity constraints. So our point 1 is 0, 0. Our point 2 is 0 and 4.2. This is our point 1, this is our point 2. So our point 3 is, we solve this point 3 later. So our last point is 12 and 0. So our intersection now is this. Since the constraints is less than or equal to constraints, this satisfies in the region below the line. Therefore, our feasible region in this area. So this is our feasible region. So we must solve this intersection coordinate points to get the best optimal solution. So let's start to solve this one. Our equation 1 is 2x plus 4y equals 24. So by using addition property of equality, so we can solve this one. So 2x equals 24 minus 4y. So divide both side by 2 to get our initial value for x. So our x now is 12y minus 2y, because 24 divided 2 is 12, then 4 divided 2 is 2y. So this is our initial value for our x. We can use it to substitute in the equation 2 in the value to get the value of y. So in our equation 2 now is 2x plus 10y equals 42. So substitute the value of x, so 2 times 12 minus 2y plus 10y equals 42. So 2 times 12 equals 24. Then 2 times negative 2y equals negative 4y. Then copy this one, plus 10y equals 42. So we must use the addition property of equality. So we can get now a negative 4y plus 10y 42 minus 24. So simplify, we can get a 6y equals 18. So divide both sides by 6 to get our y. So divide both sides by 6. So our y now is 18 divided by 6 equals to 3. So this is our final value for y. And now we can solve the final value for x and substitute the 1. So our x equals to 12 minus, so 2, our value for y is 3. So 2 times 3 is 1. So 12 minus 2 times 3 equals 6. And now we have a final answer for our point 3. So this is our final answer for point 3. So we can plot this one in this area. So point 3 equals 6 and 3. And finally we get the value of the point 3. The intersection of point 3 is x equals to 6 and y equals to 3. So we can now plug them to the objective function to choose the best. So each one of this value, our point, plug to the objective function to get the maximum value of the LP problem. So we solve this. So our point is, our point 1 is 0, 0. Our point 2 is 0 and 4.2. And our third point is 6 and 3. Then our last one is 12 and 0. To get the maximum value of this, so our objective function is to maximize 3x plus 7y. We can now substitute the value of these coordinate points to the objective value. So if x equals to 0, so we can make it 3 times 0 plus 7 times 0. So 3 times 0 plus 7 times 0, so 0. And then the second one is 3 times 0 plus 7 times 4.2. So 3 times 0 is 0 plus 7 times 4.2 is 29.4. And then the third one is 3 times 6 plus 7 times 3, because this is the value of the point. So, and we get the answer of 39. And then the last one,
Okay.
in our point 4, the value of x is 12 and the value of y is 0. So, substitute the objective function. So, we can get 3 times 12 plus 7 times 0 is 36. Since our maximum value or the biggest value is 39, so this is our maximum value. So therefore, the optimal solution occurs in point 3 and our x is 6 and y is 3. And the corresponding objective function value is 39. And that's conclude our LP problem. That's all and thank you.